So I'm going to talk about restricted domain and range. So what is it? It's when someone, say a tester or like an examiner, makes the part of the graph you're working with smaller. Let's see, because when we can only use a small section of the graph. Yeah, we can only use a small section. So this is best done by examples. So I'm just going to give you a few examples of this. Example 1. So say we had the equation y equals 2x plus 2. And usually, because we're also smart now, we know that the domain is, x can be anything. So the domain is minus infinity to infinity, or it's all real numbers. And the same with y. We get some graph that looks like this, and we just go on forever. But what if they said the domain is restricted to, let's call it -1 to 3. Yeah. I'm going to put square brackets in, sorry. I forgot what I was doing for a second. Okay, -1 to 3. What does that actually mean? It means on our graph, our only x values we can get is -1 to 3. And now they're going to ask us, what is the range? Okay, how do we do this question? First, I'm going to draw you a graph so you kind of get an idea of what's going on. Okay, so the domain is restricted to -1 to 3. We have a graph of 2x plus 2. So let's just draw our graph first. 2x plus 2 is going to look something like this. The straight line, it hits at, well, when x equals 0, y equals 2. And when y equals 0, x equals -1. Okay? Now, we're only going to get from -1 to 3. So the only part of the graph that matters is from here to 3. Where x is 1, 2, 3. So it should be like out here somewhere. So probably from here to here. Okay? Like the rest of the graph, all this stuff doesn't matter. Now, they want to know what the range is. Well, we need to just figure out what the y values are. So the y value when x is -1 is 0. And the x value, y value when x is 3 is, we put 3 in, 2 times 3 plus 2, that's 3, 8. Okay? So now we know what our limits of our x values are, and we know the limits of the y, because y doesn't go beyond these 2 points. So our range equals 0 to 8. 0 to 8. Inclusive, because these are inclusive in black dots. Example 2. I'll give you a bit of a harder equation, but not much. Not too hard. Y equals x squared minus 2. Domain equals -1 to 3. What is the range? Is R. Okay, so for this question, what we need to do is, I like drawing the graph. So until you understand what's really going on, you're going to need to draw a graph. But see, if you think about it, for this equation, you didn't actually need to draw the graph. If you just sub in -1 to x, you get -2 plus 2 makes 0. Sub in 3, and you get 2 times 3 plus 2 is 8. And the reason that works is because we're just subbing in these x values, so we're getting at the y values, and we know they're the minimum and the maximum. Okay? Sometimes it's not so easy. For this one, how does the graph look like? X squared looks like a parabola, it looks like that. X squared minus 2 is just that, but a little bit lower. Just like that. Okay. Now, we have our domain from -1 to 3. So let's do what we did before, and we're just going to sub them in. When x equals -1, y equals -1 squared minus 2. It gives us 1 minus 2 equals -1. So we have our first point, minus 1, minus 1. When x, so let's have it on the other side, when x equals 3, y equals 3 squared minus 2 equals 9 minus 2 equals 7. So we have our second point, 3, 7. 1, 2, 3, let's make that 3, 7. So you might be tempted to say the domain is minus 1 to 7. I mean the range is minus 1 to 7. Minus 1 to 7? Question mark? Oh, we have to include it because our domain was included as well. No, because there's a lower point on this graph. If we remove all this part, what's the largest y value that we can get of our little section of graph? Our largest value is 7. But what's the lowest? The lowest part is here. The lowest point of the graph, we need that lowest point. Because y can go below minus 1. And this point is when x equals 0. And we get y equals 0 minus 2, which makes minus 2. So this point is 0 minus 2. So the key message of that example is we can't just sub in the points sometimes. More complicated graphs, we need to figure out what it actually looks like. You can do it in your head and then do it like this. If you knew that the lowest point was 0, you could just sub it in. But until you know how to do it in your head, it's better to draw a graph. On the other hand, if we have just a straight line, we know the endpoints are the highest and lowest. Okay. And I'll move on to implied domain next. Cheers.